Hey everyone, welcome to homework 5.7. This first one asks you to select all the expressions that are perfect squares. In order to be perfect squares, remember I'm multiplying the same exact thing times the same exact thing. So A is a perfect square because this could be written as x plus 5 squared. B is the same thing because the signs are correct. So we have a positive C. This could be rewritten as C minus 9 times C minus 9. Right? So B is also a perfect square. C is not a perfect square because we have a negative 10 and a positive 10. They would have to have the same signs. They need to be exactly the same. D is a perfect square because we can rewrite this one as a plus 3. And so this is a plus 3 squared. E is not. E is what we would call the difference of squares because this would cause our middle term to cancel out because we have one negative and one positive. F is not because we have a negative 3x and a negative 4x. They're different, okay? And then G is because this could be written as a plus b times a plus b. We can rewrite that. The signs are the same. We get a plus b squared. Number 2, solve each equation. So these are all perfect squares, which means that I can take the square root of all of them. So I'm going to start taking the square root of both sides. If I take the square root of a square term, all that's left is what's underneath the square root. And so this equals plus or minus 2. That's important because there's going to be more than one answer. So x minus 1 equals 2. Add 1 to both sides. You get x equals 3. Or x minus 1 equals negative 2. Add 1 to both sides. And x equals negative 1. Those are your two answers. All right. Letter B, take the square root of both sides. We get x plus 5 equals plus or minus 9. Continue to solve that. I'm not going to do that for you. Give me my answers here. All right. Letter C, same thing. Take the square root of both sides. Here it's just going to be 0. So you're not going to have a plus or minus. You will have only one possible answer because we have x minus 2 times x minus 2 equals 0. Right? Those factors are exactly the same, equaling 0. So you can solve that one on your own. D, I want you to solve completely on your own. If you have questions or you want to check your answers, you can text me. E, I will go over because there's a fraction, and I know you think fractions are scary. So if I take the square root of both sides, this is a perfect square. You might not recognize this, but this is 64 is a perfect square and 49 is a perfect square. So we get x minus 7 equals plus or minus 8 over 7. All right, that's it. That's your answer, right? Because the square root of 64 is 8 and the square root of 49 is 7. You do still need to do a plus or minus, so you should again come up with two answers. So list your two answers there for me. Number 3, Han and Jada solved the same equation with different methods. Here they are. So this is Han's method and this is Jada's method. Notice they got the same answers, right? So it says, what did each of them do? Did they make legal moves? How did they solve the equation differently but still get the same answer? So let's see what Han did. So first of all, Han had x minus 6 squared equals 25. He went ahead and he wrote this out as a perfect square, right? X minus 6 times x minus 6 equals 25. So then he went ahead and he multiplied and he FOILed it and put it into standard form. And then he subtracted 25 from both sides. So standard form, subtracted 25 from both sides. Now, why did he do that? Well, when he did that, he made this side 0. And so then he factored his new equation, the x squared minus 12x plus 11. The only factors of 11 are 11 and 1, and we have a negative 12 and a positive 11, so he knew he needed to have two negatives there. So the difference here is that he subtracted 25 from both sides. Jada, on the other hand, recognized that both x minus 6 squared and 25 are perfect squares. So she took the square root of both sides. I should do that up here. She took the square root of both sides. So square root of both sides and solved. Now Now notice both ways are perfectly valid. Both ways work. Both ways will get you an answer that is correct. She just did this in a slightly shorter way. So if you recognize that both sides of the equation are a perfect square, it'll make it faster for you to solve. Okay? So you should have something about him putting it in standard form, subtracting 25, factoring, and solving each for 0. Right? Versus Jada simply took the square root of both sides. She knows that the square root of 25 is plus or minus 5, and so she solved for her two answers that way. Number 4, add the number that would make the expression a perfect square. Next, write an equivalent expression in factored form. So to make this a perfect square, we're going to take half of it and square it. So this is negative 6x plus 9. I can write this as x minus 3 squared, or x minus 3 times x minus 3. All right, here, half of 2 is 1. 1 squared is 1. So I can also write this as x plus 1 squared. Here, half of 14 is 7. 7 squared is 49, so I'm going to add 49, and I will get x plus 7 squared. Okay? Half of negative 4 is negative 2. Negative 2 squared is positive 4, and so I can rewrite this as x minus 2 squared. And then half of 24 is 12. 12 squared is 144, so you can add 144, write that here, making sure that you're listening, and then you can write this in factored form, right? So x plus 12 times x plus 12. Notice that when we have factored form, that second term inside the factored form is half of our middle term, right? And that shows to us that this is a perfect square relationship. Number 5, Mai is solving the equation x squared plus 12x equals 13. She writes it as such. So she writes x plus 12x, x squared plus 12x equals 13. And then she rewrites this as x plus 6 squared equals 49. Jada looks at Mai's work and is confused. She doesn't see how Mai got her answer. Complete Mai's missing steps. So what we don't see here is that she needed to take half of 12. Half of 12 is 6, and then square it, so 36. And she needs to add 36 to both sides. So once she adds 36 to both sides, then she can factor and make this x plus 6 times x plus 6 equals, add these together, 49, or x plus 6 squared equals 49. Then she can take the square root of both sides, and she will get x plus 6 equals plus or minus 7. So she can do then x plus 6 equals 7, x plus 6 equals negative 7, and then you can complete the next step there. Okay, so again, that missing step, she took half of this, squared it to get 36. If she adds 36 to this side, she has to add 36 to this side. Okay? All right, number 6 is matching each equation with an equivalent match each equation to an equivalent equation with a perfect square on one side. So we want to match these up. So for this one, if I wanted to make this a perfect square, I would take half of that as 4, add 16 to both sides, so that would be x squared plus 8x plus 16 equals 18. And then this then would be x plus 4 squared equals 18. So that's number 4, right? For this one, I'm going to add 25 to both sides, and I'll end up with x plus 5 in parentheses equals 12. So that's number 2, okay? I'm going to do one more for you, and then you need to do the rest. So half of 14 is 7. 7 squared is 49, so this would be x squared minus 14x plus 49 equals 5 plus 49 is 54. And so then this would be x minus 7 squared equals 54. See that as number 1. Okay, so I've done half of them for you. You can do D, E, and F. Remember, you need to find half of the middle term and add that to both sides. All right, be careful with this one because you'll need to move that to the other side first so that you get it out of the way. Number 7 says solve each equation by completing the square. So we're going to do that. We're going to start here. We want to move this out of the way, right? So we don't need to worry about that. Solve x squared minus 6x equals 7. So then I'm going to take half of this, which is 3, and square it, which is 9. Now I have a perfect square, and so I can, oh, you know what? I forgot I have to add 9 on this side too. Don't forget to do that. See? Add 9 on both sides, okay? Then I can put this as x minus 3 squared equals 16. Take the square root of both sides, and we get x minus 3 equals plus or minus 4. You can then solve for x. Give me 2 answers for x. 1, 2. All right. This next one here, half of negative 2 is negative 1. Negative 1 squared is 1. So this will be x squared minus 2x plus 1 equals 8 plus 1. I have to do it on both sides. Now this is x minus 1 squared equals 9. Take the square root of both sides, and we get x minus 1 equals plus or minus 3. Again, solve using plus or minus 3, and give me 2 possible answers there. Our next one looks complicated, but it is not. It looks complicated because they just wrote it backwards. So if it's helpful for you, I would rewrite this as this. I'm going to add 1 both sides to clean that out, and we'll get x squared plus 4x equals 12. And then I'm going to complete the square by taking half of this and squaring it, so plus 4 on both sides. This is now perfect square. X plus 2 squared equals 16. You can take the square root of both sides and continue on. You should, again, have 2 answers. Here I have bigger numbers, but it's okay. I'm going to subtract 60 from both sides. I'll get x squared minus 18x equals negative 81. I'm going to take half of 18, which is 9, and square it. 9 squared is 81, so I'm going to add 81 to both sides. Ooh, oops. What's nice here is this is going to cancel out to be 0. So now I'll get x minus 9 squared equals 0. This means for this one, there will only be one answer, right? Because it's equal to 0. Again, make sure you find the solutions for these problems on your own. Number 8 says rewrite 8's expression in standard form. This is just practicing multiplication, but it's also helping you to recognize these are the difference of squares, which means when you do this, you will not have a middle term. You are all now fully capable enough of doing this multiplication without me, but if you recognize these are the difference of squares, you know this positive 3x and this negative 3x are going to cancel, so you'll get x squared minus 9. Okay? You can, if you want, do the whole process of foiling and do x plus 3 times x minus 3. You will still get x squared, 3x, negative 3x, minus 9. These will cancel out, and you'll be left with x squared minus 9. So you do, I hate it when that happens. You do this one, and this one on your own. Number 9 says explain or show why the product of a sum and a difference, such as 2x plus 1 times 2x minus 1, has no linear term. So that's the same thing as above, right? So you want to show me, you can use 2x plus 1 and then 2x minus 1, that they are going to cancel each other out. We'll get 4x squared plus 2x minus 2x minus 1, right? These terms here will become 0 and therefore cancel each other out. Number 10, to find the product of 203 times 197 without a calculator, Priya wrote 200 plus 3 times 200 minus 3. Very quickly and without writing anything else, she arrived at 39,991. Explain how writing the two factors as a sum and a difference may have helped Priya. So, the reason this helps is she might recognize that 200 times 200 is 40,000. Right? And you have 200 times 200. You'll recognize that as 40,000. Then you have to multiply 200 times negative 3. Right? So the same application that we had to do when we are multiplying our quadratics in factored form is we have to multiply by everything in the parentheses. However, because this is the difference of squares, she knows that what's going to happen is her middle terms are going to cancel out. She'll get 200 minus 3 is negative 600, and 200 times positive 3 is positive 600, so that'll be a net sum of 0. So then all she needs to do is do 3 times negative 3, her last terms, and this will be minus 9, which therefore gives you 39,991. So again, because she recognized that these numbers add up to be the difference of squares, she didn't need to worry about this plus 600 and minus 600 because they will cancel each other out. Again, same exact numbers, separated by the opposite sign, are your difference of squares. Number 11, our last problem. A basketball is dropped from the roof of a building and its height in feet is modeled by the function h. Here is a graph representing h. Select all the true statements about this situation. When t equals 0, the height is 0 feet. So at time is 0, the height is 50 feet. That is not true. B, the basketball falls at a constant speed. No. If the basketball fell at a constant speed, then we would have a straight line, right? The expression that defines h is linear. That is not a line, so no. The expression that defines h is quadratic. Yes, quite likely because of gravity. So you can, this looks kind of like a decay, but decay would look like that, right? So decay would be going the other direction, have a curve under instead of a rounded curve up. When t equals 0, the ball is about 50 feet above the ground. Yes, that is true. The basketball lands on the ground at about 1.75 seconds. Yeah, that's about 1.5. That's about 1.75. That looks good. So it takes it about 1 3/4 seconds to hit the ground. All right, that is your classwork or your homework for today. Your code word today is going to be eagle. Eagle is your code word. Put that at the top of your homework for extra credit if you watch this video all the way through. If you have questions about anything that I didn't go over specifically, you can text me and ask me, is this correct? And I will check it. Happy homeworking, and I will see you on Monday.